Welcome to the Mathematics in my channel. Today we are going to solve another interesting integral question. The question is 0 to integral from 0 to 1 natural log of gamma of x times cosine square of pi x dx. Okay, first I am going to take this integral is equal to I, and then we know this property of integration 0 to a f of x dx is equal to 0 to a f of a minus x dx. Okay, now we can apply this theory for our question. So we can write this is equal to 0 to 1 natural log of gamma of 1 minus x times cosine square of, now instead of x we can plug in 1 minus x, so cosine square of pi minus pi x dx. Okay, then we can simplify this. So here this is equal to 0 to 1 natural log of gamma of 1 minus x, here cosine square of pi minus pi x. We know cosine square of pi x dx. Well, now here we know this is also equal to I. Now we can sum I plus I, so 2 times I is equal to 0 to 1 here natural log of gamma of x cosine square of pi x, same limit, so here plus natural log of gamma of 1 minus x cosine square of pi x dx. Well, now we know cosine square of pi x is a constant, is a common factor, so we can write 0 to 1 natural log of gamma of x plus natural log of gamma of 1 minus x times cosine square of pi x dx. Then according to property of natural log of gamma of x plus natural log of gamma of 1 minus x, we can write natural log of gamma of x times gamma of 1 minus x times cosine square of pi x dx. Now this is familiar with us because we know Euler's reflection formula. So gamma of x, gamma of 1 minus x is equal to pi over sine of pi x. Now we can plug in here, so we can write 0 to 1 natural log of, now instead of gamma of x, gamma of 1 minus x, we can plug in pi over sine of pi x, here cosine square of pi x dx. Okay, then we take 2 times I, so 2 times I is equal to, now again according to property of natural log, this division we can write as a minus sign, using minus sign, so we can write 0 to 1 natural log of pi minus natural log of sine pi x, and we need to multiply by cosine square of pi x, so we can write natural log of pi times cosine square of pi x dx minus 0 to 1 natural log of sine of pi x times cosine square of pi x dx. Okay, then we can take here, this is now again two different integrals, so we can take this is equal to I1 and this is equal to I2, and we know 2 times I is equal to I1 plus I2. Now I am going to take I1. So I1 is equal to, here natural log of 5 we know constant, so natural log of 5 0 to 1 cosine square of pi x dx, and now I am going to use the substitution. So if we take pi x is equal to t, now differentiate, so pi dx is equal to dt, and limit x approaches to 0, t approaches to 0, when x approaches to 1, t approaches to pi. So now we can plug in here, so natural log of pi, now limit 0 to pi, now cosine square of phi x is equal to t, dx is equal to dt over phi. So phi is a constant, so we can write outside of the integral sign. Okay, now natural log of pi over pi, here 0 to pi, we know cosine square of t is equal to 1 plus cosine 2 times t over 2 dt, and then natural log of pi over pi, here 2 is a common factor, so 1 over 2, and here dt, so t plus integral of cosine of 2 of t, so sine of 2 of t over 2 limit 0 to pi. So here natural log of pi over pi, here 1 over 2, and if we plug in pi, here this is equal to 0, if we plug in 0 also 0, so here only we have pi. Now pi is get cancelled, so this is equal to natural log of pi over 2. Well, now I2, so I2 is equal to 0 to 1 natural log of sine of pi x, here cosine square of pi x dx. Okay, then we can write this is equal to 0 to 1, here I am rewrite natural log of sine of pi x, and cosine square of pi x we can write 1 plus cosine of 2 pi x over 2 dx. Now 2 is a common factor, and we can multiply by natural log of sine of pi x, so we can write here 1 over 2, 0 to 1, if we multiply by natural log of sine of pi x by 1, so we can write natural log of sine of pi x dx, then plus 1/2 0 to 1 natural log of sine of pi x times cosine of 2 pi x dx. Okay, then we can take here, this integral is equal to I3, and this integral is equal to I4. Now I3 Now I'm going to do it I3. So I3 is equal to here 1 over 2, and we can use substitution method. So if we take phi x is equal to u, so phi x is equal to u, phi dx is equal to du, and limit when x approaches to 0, u approaches to also 0, when x approaches to 1, u approaches to pi. So we can write here 1/2, now 0 to pi, natural log of sine of u, now dx is equal to du over pi. So du over pi, pi is a constant, so 1 over pi. Now here I took I3 is equal to 0 to 1 natural log of sine of pi x dx. This 1/2 I'm not going to take. Okay, now here 1 over pi, and here 0 to pi. Now this is familiar with us. Now this is symmetric, so if we can take here 2. Now limits, upper limit change, 0 to pi over 2 natural log of sine of u du. Now here 2 over pi. Now this is famous integral, 0 to pi over 2 natural log of sine of x dx. In a previous video we discussed about this integral. So if you like to watch, I will add the link in the description, and also make a card. So we know the answer of this integral, minus pi over 2 natural log of 2. So pi get cancelled, 2 also get cancelled, and here this is equal to minus natural log of 2. Now I'm going to take I4. So I4 is equal to 0 to 1 natural log of sine of pi x, here cosine of 2 pi x dx. Now okay, then we can use again substitution method, use substitution. So we can take phi x is equal to v, so pi dx is equal to dv, and limit also 0 to pi. Okay, so we can write here this is equal to 0 to pi natural log of sine of v and cosine of 2 times v. Now dx is equal to, we know, dv over pi. So dv over pi we can write in here. Okay, then 0 to 5 natural log of sine of v cosine of 2 times v. So what can we do? Now we can integrate by using parts method. So we can take here 1 over pi, 0 to pi. Now I'm going to take natural log of sine v as a first function u. So natural log of sine of v, now d by dv. Now integral of cosine of 2v, we know sine of 2v over 2 dv, then 1 over 5 product of these two functions. So here 2 is a constant. Okay, now we can write natural log of sine of v, sine of 2 times v, here 2 minus now 0 to pi. First rewrite this function, so 1 over 2, and here we have 1 over pi, so also 1 over pi, here minus sign, and now here sine of 2v. Now derivative of this function, so 1 over sine of v, and according to chain rule, derivative of sine of v, we know cosine of v dv. Here limit 0 to pi, so if we plug in pi here, sine of pi is, we know 0. If we plug in 0, also 0, so this is going to 0. Now 0 minus 1 over 2 times pi, here 0 to pi. Now sine of 2v, we know double angle formula, 2 times sine of v cosine of v times this cosine of v, cosine square of v over sine of v dv. Now this sine of v get cancelled, and we have this 2 also get cancelled, minus 1 over pi, minus 1 over pi, integral of from 0 to pi, integral of here cosine square of v, so we know 1 plus cosine of 2v over 2 dv sorry, cosine of 2v over 2 dv. Okay, now we know this is I4, so now I4 is equal to minus 1 over pi, here 2 is a constant, so 2 pi, now here v plus sine of 2v over v 0 to pi. Okay, then I4 is equal to minus 1 over 2 times pi, we know here only pi, so now pi get cancelled, and this is equal to minus 1 over 2. Okay, now we evaluated I1, I2, I3 and I4. So our integral, our question I, so we know 2 times I is equal to I1 minus I2, so 2 times I is equal to I1 minus I2, and we evaluated I1, so I1 is equal to natural log of 5 over 2, so here natural log of 5 over 2 minus now I2 we know, here I2 we know 1/2 times I3 plus 1/2 times I4, so 1/2 is a constant, so 1/2 I3 plus I4. Now I3, we know I3 is equal to minus natural log of 2, so we can write natural log of 5 over 2 minus 1/2. Now I3 minus natural log of 2, here plus I4, we evaluated I4, we know I4 is equal to minus 1/2, so we can write here minus 1/2. Okay, now we can simplify, here natural log of pi over 2, here plus natural log of 2 over 2, here again plus 1 over 4. Now natural log of pi plus natural log of 2 over 2 plus 1 over 4, and according to property of natural log we can write here natural log of 2 times pi over 2 plus 1 over 4. Okay, this is equal to, we know 2 times I, but we need I. So I is equal to natural log of 2 times pi over 4 plus 1 over 8. Okay, this is the answer. If you like this video, please subscribe this channel. Thank you for watching.